The C++ enumerated type called enum is a very useful thing. Here I have a working copy of enum.cpp from chapter 5 of the exercise files. What's really interesting about this is that while it looks syntactically like a type, and it's even referred to as a type, it's not really a type in the same way as other types are. Enumerated names actually work more like constants than like types, and they make a great alternative to preprocessor constants. So this is actually more code than we usually have in our examples, and I'm going to go ahead and build and run this so you can see what it does. What it does here is it lists out an entire deck of cards in order: ace of spades, deuce of spades, 3, 4, 5, 6, jack, queen, king of spades, and then the same for hearts and diamonds and clubs. And so it's listing out this entire deck of 52 cards. Here we have an array of cards, a structure to represent the cards themselves, including rank and suit, and then this array of cards that gets initialized: ace of spades, deuce of spades, 3 of spades, like that, jack, queen, king of spades. And then you'll notice that I switch to using numbers instead of the enum constants. That's just because I wanted to show you their equivalents, and we'll get to that in a moment. Then we print the cards using a switch for the ace, jack, queen, king, and deuce that print out from these string constants up here: ace, jack, queen, and we also have the spades, hearts, diamonds, and clubs there. And we print out the suits the same way with another switch statement. So this is actually pretty straightforward. What makes it long is the switch statements and the data definitions. So let's take a look at the enum. The keyword enum followed by the name of the enum and an initializer list with the symbols that are going to be used for the enums. If we care about the values of them, in the case of spades, hearts, diamonds, and clubs, they're only ever used like that down here in the switch statement. So we don't really care what their values are, but if we do care, we can give them values like this. And you'll notice that I don't give values to king and queen because by definition, they're going to be sequential after the 11. Now, enum by default has an underlying type of int. And so since I haven't specified anything else here, these are all treated as ints. And so when I initialize our array, you notice that the structure for card has unsigned characters for rank and suit. And so ints will naturally promote to any scalar integer type, including unsigned char. And so I can initialize them with these enums, and you see that each of these at least has a suit enum. In the case of ace, deuce, jack, queen, and king, I use them interchangeably. I used 1, 2, and 11, 12, and 13, just as I used the enums, and they can be used interchangeably because as far as the compiler is concerned, they resolve to the same thing. So it really is that simple. I could have used numbers here, and I could have used numbers in the switch statements, but the code wouldn't have been as clear. I could have used preprocessor constants, and that would have also worked, but then they're not typed and they're not in the symbol table in the compiler. And so for many uses, constants may be a better choice if you need something other than a scalar value, but enum is often a great alternative to preprocessor constants. And for some uses, the enum type can be very handy, as here, for grouping scalar constants together when they have a common usage.